Hello and welcome to DataBasic, a Warwick Data Science Society podcast aimed at making data science simple and accessible by discussing the latest developments in the field. I'm Yasser Qureshi, a third-year systems engineering student, and in this episode we'll be discussing the latest new developments going on in society, the impacts the society is having, and asking what you want to see in future episodes. There will also be a short segment talking about the basics of Bayesian thinking. So let's get right to it. Welcome to the first episode of DataBasic. You must be wondering what to expect on our episodes. Well, I won't be the only host. We'll have revolving hosts, and we'll bring in knowledgeable and experienced guests in the future, as well as sharing some student-led work. Currently, in the society, we have a lot going on. Firstly, we have our summer coding crash course starting next week. These are courses that are designed for complete beginners, with the goal of giving people tools to learn more by themselves. We'll be teaching both Python and R, and we'll have one taught session per week, with students expected to put some time aside to work through a few exercise sheets by themselves. There'll also be mentors available to solve any issues, to motivate and to discuss long-term goals for learning to code. We'll have group chats set up, one for the whole cohort, as well as smaller groups with mentors, all to create a small community of learners. We want to make learning as simple as possible, so everything will be done on the cloud, so no need to install any hardware or set up the coding environment. Material should be easily accessible, and worksheets offer a template to guide you through writing code. So far, adoption has been incredible. With over 250 signups, we've had to drastically scale up our operations to try and meet this demand, and we've only just fulfilled it. If you've missed this, or you feel you already have good coding knowledge, don't worry. We'll be running more iterations as well as more advanced and domain-specific courses in the future, so keep an eye on our socials, links in the description. We also have our research blog. We want to make student-led research as simple as possible and share amazing work being done by Warwick students. For example, one of my favourite posts so far is about performing arithmetic with words using a language model known as Word2Vec. You can read more at research.warwickdatascience.com. We have a lot of plans to roll out more involvement, as well as how we support research, such as offering infrastructure, matching skills, and project ideas. More details will be both on our blog and socials very soon. We are proud to say we've had over 400 attendees for our last 3 talks. This is a great achievement, and we plan to continue to do more talks with other academic societies to make it clear how data science can be leveraged in every domain, as well as diving into some more topics focused on data science itself. Things like ethics, statistical thinking, and machine learning. We'll be right back after this segment. Hey everyone, I'm joined here with Tim. Today we'll be having a quick chat about the basics of Bayesian thinking. So Tim, I've heard the word Bayesian being thrown around a lot. For example, I've heard Stuart Russell, often referred to as the godfather of AI, mention it will revolutionize the way we solve problems. It's clearly got a lot of potential, but it isn't always the clearest what it means in practice.
Exactly. All too often you can find managers interrogating their data scientists over whether their machine learning tools, such as neural networks, are of the Bayesian variety, without really understanding the implications of the Bayesian framework. For that reason, I'm glad we had this chance to offer some insight into what exactly Bayesian thinking involves.
Perfect. Do you have a high-level example we can work through so we could better understand how Bayesian thinking works?
I do indeed. You don't happen to have a dog, do you?
Unfortunately, I don't.
Well, in that case, we'll have to make one up for this example. Let's say you need to take this dog for its regular checkup at the vet. You carry them in and pass them over to the vet to get weighed. Now, unfortunately, your dog isn't the biggest fan of this experience, and so won't stop wriggling around as the vet tries to weigh them. To account for this, the vet weighs the dog 3 times, resulting in the measurements 14, 16, and 3 kilograms. The naive way to continue would then be to average these out to get a final weight of 11 kilograms. Sound good?
But 3 kilograms? That's a bit light for a dog. Is that not an outlier, so should we not remove it to get a better weight for the dog?
Well spotted. That would make a lot of sense in this case, and leave us with a much stronger estimate. Suppose, however, that the measured weights were 14, 1, and 3 kilograms. Now, 14 kilograms is the outlier, so I assume you would remove that to get a weight of 2 kilograms?
No, I'd still get rid of the 1 and 3 kilograms.
That's interesting. What led you to that decision?
Well, I have a general idea of what a dog would weigh, and the weights of 1 and 3 kilograms just don't seem right.
Spot on. And it turns out that you've just given a rough description of Bayesian statistics. The key to Bayesian thinking is not only to look at the data you observe, but also account for your initial beliefs, which we call priors.
So in this case, the priors would be my initial understanding of how much a dog weighs, and the observations are the measured weight of my dog.
That's right. In a non-Bayesian setting, we would simply look at the measured weights and average them out to obtain our best estimate of the actual weight. With the Bayesian approach that you used, however, you took into account both the observations and your prior beliefs to produce what is likely a stronger estimate. This way of thinking is formulated mathematically in what is known as Bayes' theorem. This gives us an exact way of combining our observations and priors together, but the intuition is exactly the same.
Okay, I see. Could we work through an example involving some numbers so we can see what an answer would look like?
We certainly can. How about we continue with the example where the measurements were 14, 1, and 3 kilograms? We'll first have to decide what your prior beliefs look like in terms of what your guess is and how confident you are in it.
So I would say I'm about 90% sure my dog's weight would be in the region of 8 to 10 kilograms.
Great. Well, I've done the calculations, and Bayes' theorem tells us that your best estimate is 8.9 kilograms. We can compare this to the 6 kilograms we would have obtained by simply averaging the 3 measurements. It's clear that Bayes' theorem took into account your initial beliefs to pull this estimate up.
That sounds great. So why don't we use Bayesian statistics for everything?
That's a good question. There are 2 main reasons that I can think of. For a start, there's a reason I didn't share my Bayesian calculations before. They're not the prettiest. In fact, the main limiting factor of Bayesian statistics is that they can often require a lot of computational power compared to simpler, non-Bayesian methods. On top of that, the efficacy of Bayesian methods depends heavily on whether your prior beliefs are reasonable.
Okay, so if I really believed my dog weighed 1 ton, then that would have a massive negative effect on our results.
That's the exact risk we run. When we have these limitations under control, however, Bayesian thinking is an incredible tool for producing better predictions with the data we have available.
That sounds great. So to sum up, Bayesian thinking takes into account prior beliefs as well as observed data to create more reliable estimates. Thanks, Tim. I definitely have a better understanding of what Bayesian thinking looks like in practice.
No problem. It's been great to chat. And remember, an imaginary dog is for life, not just the podcast.
So we want to know what you want to hear on our podcast. Send us any suggestions you have to podcast.warwickdatascience.com/suggestions. Or if you have any general inquiries, you can email us at hello@warwickdatascience.com. Next time, we'll be joined by Hannes Smith, and we'll be discussing the programming language Julia and whether it is a skill you should be developing. Don't forget to subscribe to our YouTube channel and follow us on Facebook, LinkedIn, and Instagram to keep up to date with the podcast and the society. Thank you for listening, and we'll see you next time.